Hello Internet, in this video we are going to be looking at some matrix multiplication. Specifically we're going to be looking at rotational matrices in 3 dimensions. So I've kind of been building this project for the past 30 minutes, but what I'm trying to build is sort of a fancy box, and so what it is it is a, that's not going to work, is it? But it's a complicated box, so there are 8 by 8, it's a box made of 8 by 8 cells. So there's 9 vertices per side, because there's an extra one for the extra side. But anyway, what this does is it allows us to modify these vertices. So like I can skew right now, which is I just kind of threw together to make sure this actually worked. And so what this does is actually in our vertex shader, it's actually modifying what our mesh is doing. So I can actually stretch this on any side. And there's an offset here, so the default is at the center of this model. I have it down -1 because the model is 2 by 2. So by moving the origin down by -1, we get it at the bottom. And then I just use the y value, or the height, relative to the object to actually determine how much to skew. So it kind of creates like a linear scale. And so that's, yeah, basic stuff. We can do x, y, and z. Y just moves it up and down, which is kind of lame. But the other ones, you can kind of get the skew. And if you send them to 0, you get back to normal. So what we're going to be looking at are using these. So there are, I'm going to use each plane separately, but there's an X, a Y, and a Z plane or rotational matrix, which will take a 3-dimensional vector. And if you multiply that by this, you are going to get a rotated thing. And so this way we can actually rotate all of our vertices around the origin, and hopefully we'll get something interesting. I have no idea how this is going to work. I have never done this in Unity before, but if you've ever needed to do matrix multiplication or rotate anything, this is how you would do it. This is the 3-dimensional formulas. There's 2-dimensional formulas. They're easier. But we're working in 3 dimensions, so we need the 3-dimensional formulas. I'm not going to go over what these are or how they work in this video. There's other resources that will get you there, and I might come back and cover them, but that's something that I'd want to leave for something else. But effectively, it allows you to translate in a point around the origin. So all of these rotations that we're applying are going to be around an origin. So if I have a point, like this is my origin here, and this is my not origin, the point I want to translate. If I apply like an X or a Y rotation, that rotate it around the Y axis, so straight up, it will rotate like this around the origin. And so that's going to work, but this is going to do it in any of the 3 dimensions. So theoretically, by applying each of these things, we can get X, Y, and Z rotation. So what I want to do is actually apply how much rotation is actually going to be there. So let's create that. So we're going to do a rotation and give it a vector. Sure. So we'll initialize this to 0, just for easiness, I guess, and set our rotation to a float floor of rotation. So actually pass it in, and then these are actually taken off of the Wikipedia page for rotational matrices. I'll post that in the description, so you can go check that out. They have a few other transformation matrices. There's some for scaling. Scale is actually super easy if you just take it along the identity matrix. So the identity matrix looks like 1s along the diagonal from top left to bottom right. If you take that identity matrix and just scale those 1s, you actually get just a scale, a linear scale. So anyway, that's totally outside of where I wanted to go with this. What we want to do, I'm just going to try to get the Y working so we can scale it around the Y axis. And then we can do the other 2 later-ish. So here's the code that I have right now. What we have is we have a modifier, which is how much of the current modification we're going to apply at that point. And so that's the current y offset of the model, and then there's an offset. So the way this works is like our origin for this cube, it's just something I've made in Blender, but it's actually, if I set this to 0, it's actually right in the center. So we need an offset to kick that origin to the bottom, because if I set this offset to 0 so it has no effect, when I start skewing this, that's not going to work. That's the rotation. But when I start skewing this, both sides are going to move, but you'll see the middle stays in the middle. So what I want to do is actually move that offset down so that that part is actually grounded. And as I change this skew, everything else is affected, but the actual effect is 0 at the bottom. That's what we're trying to maintain. And then here we have our skew, and this is how we're applying it. We're just taking this and actually modifying our current object by that. And so that will just shift it. So again, the skew is just a little basic example. There's one more thing I want to call out. I had to change a few extra things. So you just add the vertex shader by doing vertex vert and giving it the function. But if you actually want the shadows to work, you can actually pull these out. You need to add these things. So add shadow, full forward shadows, and no light map. The reason you do that is because the light mapping is going to be based off of the mesh, which won't really work if you're making it dynamic. So if you like start animating it, all the light mapping is going to get wrong as soon as you change any of that. If you don't add shadows, this happens. So you get a projection of a shadow based upon the box. So what's actually happening is shadows look correct while this is here, but as soon as I shift this, suddenly they get really funky. And so that's why you need that add shadow pass. Otherwise, it doesn't work. So let's create a function that is going to rotate this. So I think what I want to take something that's going to return a float 3. So the modification, and we're going to just say rotate y. So this is going to include our y matrix. And so it's going to rotate some vertex around the y. So we'll give it our vertex, and we're going to need some amount of rotation. So we get our very nice formatting there. Let's take that and actually rotate it. So what I want to do is I want to build this matrix. And so what we do here is do a 4x4 matrix. We're doing 4-dimensional matrices. For what we're doing, it doesn't particularly matter that much, but there are cases where this little 1 here comes into play. So we're going to do that. I'm not going to cover that here, partially because I'm slightly hazy on that homogenization and stuff, but I'll try to find a link to some resource that you can look at if you want to learn more, and you can go check that out. It'll be in the description, so hopefully I don't forget, but we'll see. So anyway, 4x4 matrix, which means we're actually going to need a 4-dimensional vector or float here. So I can do float 4 of our vertex, and that's going to actually just be a float 4 of our vertex and 0. That may need to be 1. We'll have to see. If it gets us the wrong result, we'll change this to 1. And again, there's corrections that are happening in this matrix that make it so it actually works, because otherwise you get a little bit of funkiness. But anyway, we are going to do our matrix, whatever. We're going to call it a mat. Yeah, sure. And then I need to actually set this. I don't know a good way to do this. So we're going to do something like this. So this is effectively just a 4x4 array. And so the easy way is just to set the first row like this, and just do float 4. We're doing y, so we're going to do a cosine of our rotation, and then 0, and then the sine of our rotation, and then 0. And then we just need to repeat this 4 times for each of these rows. So let me do that. Let's plug in a 1 there. Maybe not set it to override, that'd be good. And then let's plug in some zeros here. That shouldn't be a 0. There we go. Set this to be our third. So it's rows by columns. So these numbers here represent the rows that we're working with. And then each of the values in this float, this float array, represent the columns. So our next value is 0, 1, and 0. And then this is going to be a negative sign, 0, and then the cosine, like so. And so this should be all we need for our matrix stuff. And then all I need to do is return the multiplication of this matrix by our vertex that we calculated. And then I just want the x, y, and z results from that. And so theoretically, assuming I did everything right, which is a big question because I've never actually done this in HLSL before, and I don't even think I've done it in GLSL. I've done it a lot in C++, but never like this. So we're going to see if this works, and if it doesn't, oops. So this should rotate something along the y-axis, and so I can take that out. That was just me figuring things out, and I think that can go away too. And so we've got our skew happening here. What I want to do now is actually modify our vertex. What's the best way to do this? Sure. So we're going to take our modification plus our rotation y, and we need to plug in the new vertex that we're going to be working with, which is just v.vertex.xyz, which will be our x, y, and z for the current object's vertex in object space. That's key because if you start doing this in world space, it's not going to work. So there you go. We have our vertex taken from our mesh, plugged in here, and then we just need a rotational amount, which is going to be our rotation dot y. So this will represent the y, the rotation about the y-axis. And then we want to multiply that by the modifier. And so what we're doing by multiplying it by that modifier is this modifier is, again, it affects it based off of the height. So for x and z, we may want something different, but this should work here. And what I'm expecting to happen is like we should get a twist. So that cube should slowly twist around the y-axis. Assuming I did this right. I have no idea if that's the case. Nope. Good. Unexpected identifier V. Expected one of that. We forgot a semicolon. There we go. Let's try that again. Oops, that's going to open Unity. What? Why is it bigger? Go away. Cool. Ha, so it does work. So that's good. So we can rotate this. It gets a little bit funky the more you go, but why are we getting some... I know why. Remember when I said that I think that's a 0? I meant it should be a 1. That's... Oh, come on. No. I could have sworn that was the case. I mean, that's cool, but it wasn't what I wanted. Okay, this is new to me. So what I was expecting is that this should rotate it and it should keep everything equidistant. That doesn't appear to be happening, and I'm not entirely sure why. Cool thing is well, that's not going to change it, but I can still skew everything even with the twist, and it all works. But why do you collapse? So something's causing it to get smaller as it goes up. And I don't... I don't know what would cause that. Actually, hold on. Ha! Got it. So we have this plus here. Let's take that out. I think that might be our problem because we're adding our vector again, which is why it doubled in size. And so that would explain why it got smaller as well. Because we're taking the current position and then we're adding the rotation. So if I take that back out, this should get small again. Shouldn't be where I thought. What? Okay, now what? I saved you, right? Yes? Okay. Oh, ha. This isn't gonna work. We need to move this down here and actually this is okay. I'm getting ahead of myself. Instead, let's set the vertex to be at this new position. So we still have our modifier that we're going to increase. Our skew is going to be added on afterwards. And I'm not sure that's the best solution here, but it's what we went with. So we're kind of, well, we're not actually stuck with it. Is that a good idea? Let's find out. Well, actually, first let's make sure this works, and then let's find out. There we go. Got it. So this is going to be our twist, and you'll see it actually stays the correct size. Gets a little bit funky when you do it too much because there's not enough polygons here. But if you make this cube a little bit more dense, then it should work. And this, I believe, is based off of radians. So something is going to be, I don't know, pi divided by 4? Whatever, that's what we need. But anyway, there you go. Now we have a twist, and it actually looks like a twist. And it can go in any direction and do all that fun stuff. And since it's a shader parameter, so you can kind of edit this at runtime and it all does its thing and you get kind of proper shadows. You're getting some lines here. And I don't know how to fix those, but it's a thing. So, yeah. And now, the other thing I want to do is change this skew, because what this is doing is it modifies it, but it modifies it after the fact. So what I'm thinking is, if instead of doing that, what if we took our vertex.xyz and added that skew onto it initially, which means we can take that entire thing and get rid of it, or not. And that. So that's no longer needed. And so instead of calculating a bunch of modifications, what we're doing is actually just creating something. So hopefully, there we go. Yeah, so now, if I'm correct, we get some fun stuff. Because what happens is we actually are skewing things and then we're rotating them. And so I can apply this skew like so, and we get this sort of like helix thing going on, which is kind of cool. It's not really a skew anymore. It's sort of funky. But you can, I don't know, you can do whatever you want with it, really, which is kind of neat. That's kind of going all over the place, isn't it? I don't know why it keeps disappearing, and some of this is not probably good. Like, we lost our shadows underneath here. And I think that might just be the scale is a little bit off. So if I reduce that a bunch. Yeah, it doesn't make sense why it's going away still, but I don't know how to fix that. I may have to do some research there, because that's a little bit funky for me. But it works. We get stuff. I don't know what else to call this, but effectively what you can do now is you can continue to like add these on. So we have, that's the wrong project, but we have 2 other rotational matrices we can add. And we can also add like shifts and stuff. So even with the way we're doing all of this, even just moving, shifting all of the vertices, left, right, up, down, whatever, is going to have a pretty significant effect. Because say you have your cube here, if I take that and move it to, say, the right, and then rotate it about like the z-axis, I can rotate that around the z-axis, and the entire thing is going to curve in an arc over that. So we can actually curve our box around a point just by doing that, which is cool. Let me go and implement that, because all I need to do is just copy both of these, and then we should have that. I'll probably add an offset too, which will just be like the skew, but it will affect everything regardless of weight. And that should get us to a cool point, and then we can actually kind of play with this. So, be right back. Okay, so I have it sort of working. I have the rotational stuff in, so we can kind of rotate that, and I have the offset stuff working. The one thing that I'm noticing is everything is still based off of that Y. And so that doesn't really work for these rotational things, because you'll notice it's bending right around 0, which even if I put that at the bottom, we can bend things over, which maybe that's what we want. But that's kind of cool. But what if I move this out, if I move this, I guess that kind of works. But you'll see it kind of, I don't know, it gets huge apparently. But it's all sort of set based off of that Y. So what happens is nothing really changes until I like raise the Y, and then it kind of gets all weird. Does that. And so I'm not entirely sure if that's what I want, but that's kind of cool. But anyway, I'll play around with this. I don't know where we're gonna go with this. This was just, I was curious, I guess. Is that the answer that I'm looking for? Also, selection is totally broken now. I can't click anywhere on this to select it. I have to click down there somewhere. So where the old cube was to pick something, which is, I don't know, it works. So anyway, this is certainly a thing. I don't know where to take this. If you guys have any ideas, let me know, and we can certainly look into those. This was just something that I was kind of thinking of. I was like, oh, this will be fun. And I don't know, I hope it sort of illustrates how all of this works. Because you've probably seen me multiply matrices before and maybe never known why that happens, especially if you've never used 3D graphics before. That's how 3D graphics works. Everything you see on this screen is just projections. It's all matrices. All of the rotations, all of the, scales, the perspectives, that's all done with matrices. And that's why you use that multiplication function to multiply it by the MVP. Like when you see somebody go, multiply by the unity matrix MVP, and you multiply something by that, what this is doing is actually very similar to this. It's more compact, obviously. It's not doing this. It's got most of these filled, but it's the same idea. It's controlling the scale. It's actually doing it 3 times. You've got 3 matrices that have all been multiplied together to get you that matrix. And so that's how it all works. And it's black magic. But it's cool. Really, really cool. And when you start to figure out how this all works, you can do a lot of fun stuff with it. This is just ridiculous. This has no point whatsoever besides to be interesting. And maybe if you're building something around a box as your main character and you want to animate them in a cool way, this kind of gives you a fun way to do it. You can twist something and then untwist it and maybe jump. And actually, I think that will... Is that modifying it? I can't... Actually, yeah, it kind of was, but anyway, it kind of plays with things, and that, I don't know, I think that's cool. So I'm going to leave it here. If there's any ideas you guys have, anything you want me to check out or do or whatever, let me know in the comments, and I'll certainly do that. If you guys have any ideas for like ways to improve my channel or these kind of videos, let me know. I'm open to criticism, so if you have a way to make things better or change things or whatever, let me know and I'll see what I can do. But that's it for this video. We are going to be starting a game jam Thursday. I think Thursday. I'd have to check the dates. Pretty sure it's Thursday. It's Thursday. So we're doing the, what's it called? Summer slow jams, which starts Thursday and runs, I think, a week and a half, 2 weeks. And so we're going to be doing a collaborative game, hopefully getting some mixer integration. I'm really, really hoping we can finally make that a thing. But the first initial, I'm planning on doing live streams, but the first few parts aren't going to be. I have some work stuff that kind of prevents me from live streaming during that time, but hopefully there'll still be videos about it. It's going to be tight, so I'm probably not going to have much time to screw around. But anyway, that's coming up, and it'd be cool if you guys wanted to pitch in or had ideas to change it, because it's going to be that kind of game. So yeah, anyway, I was going to end and then I thought of that. But yeah, that's it for this video. So until next time, see you, Internet.